Hey guys, I'm here right now to show you guys how to use the information off of the periodic table in order to create a Lewis dot structure and then answer some questions. So let's first look at our periodic table of elements. And just to make it easy to start, I'm going to choose lithium. And if we look at lithium and we look at the box on the periodic table, we see that there's a number at the top that says 3. There's the symbol Li for lithium, and then there's 6.9. So I'm going to round it just to 7. I'm getting that information here on our periodic table. So then let's take a look at what that looks like on our paper. So I drew out the box, and now I'm going to notice that this top number here, that's what we call our atomic number. Okay, our atomic number. And that's going to give us the number of protons. Okay, atomic number is the number of protons. And we know that protons have a positive charge. Our bottom number is going to be our atomic mass. And our atomic mass is going to be the number of protons plus the number of neutrons. Okay? And again, we know that our protons, they are going to have that positive charge, and neutrons are going to have a 0 charge. All right. So when we look at this, then we can do a little bit of math even in our heads. So we know that if we know the number of positive charges, that has to equal the negative charges. So if we know the number of protons, then we also know the number of electrons. So for lithium, we know that there is going to be 3 positive charges. So that means there also has to be 3 negative charges. And our negative charges are electrons. In order to then figure out in a problem, it might ask you number of protons, number of electrons, and number of neutrons. How can we do all of that math? Well, our protons and electrons are super easy. All you have to do is look at your atomic number. So lithium has 3 protons and 3 electrons. But our number of neutrons, that's the one that's going to be a little bit different. That is how we're going to take our atomic mass of 7, subtract the number of protons, which is 3 for lithium, and that will give us 4. Okay, to draw this out, I'm going to use some different colored markers that should help us. But I'm going to use a green marker to represent the protons. I'm going to use this blue marker to represent the electrons. And I'm going to use this orange marker to represent the neutrons. So we know that protons and electrons are the atomic mass. They're the ones that are making up the amount of space, or taking up the amount of space in the nucleus of our atom. So we're going to draw our 3 protons, 1, 2, and 3 protons. And then we are going to draw our 3 neutrons, or 4 neutrons, I'm sorry, 1, 2, 3, 4 neutrons in the nucleus of our atom. Then we are going to make our shells. Now, our first electron shell, the one closest to the nucleus, it can only hold 2 electrons. 2 electrons. That's its max number. We know that we have 3, so we're going to put our first 2 onto that shell. Then I'm going to draw this shell here. I've got 1 more electron left. Where can I put it? I can put it in this second shell. That second shell can hold up to 8 electrons. That's the octet rule. And basically, it only needs to hold 1 in this example because we only have 3 electrons to hold, but it can hold up to 8 total. Let's take a look at another example from our periodic table, maybe a slightly larger atom, and we can flip our page on this Rocket Book to a blank page. But let's look at, how about fluorine? That'll be a good one. So if we look at fluorine from the periodic table, we see that fluorine has the symbol F. It has a 9 on the top, and it has 19 as the atomic mass. So atomic number of 9, I'm going to round it here to 19 to be our atomic mass. You won't ever have to round. That would be done for you already. So here's my fluorine, and I want to know the number of protons, number of electrons, and number of neutrons that fluorine has. I'll let it catch up. Okay, in order to do that, we need to look first at our atomic number and then our atomic mass. If we look at our atomic number tells us the number of protons. So our number of protons is, I'll give you a second. You might want to pause the video if you're someone who wants to do it on their own, but it is 9. We know that protons have a positive charge. So if we know the number of positive charged particles, we have to know the number of negative charged particles because it needs to be the same. Our negative charged particles are the electrons. So if we have 9 positive protons, we have 9 negative electrons. In order to find the number of neutrons, we need to do a little bit of math. We need to do atomic number minus, atomic mass minus number of protons. Right? A little bit of math. So we need to take 19, subtract 9, and that means that there are 10 neutrons. And I'll let the cast catch up. Okay. Same as last time, I'm going to use green for my protons. I'm going to use this orange for my electrons. Or no, I didn't use orange for electrons last time. I used blue for electrons, and I will use orange for the neutrons. All right, so let's give it a drawing then. So the first thing I need to do is put my protons and my neutrons into the nucleus. So I'm going to draw 9 protons. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to put my 10 neutrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'll let this snap cast catch up. Okay, so there is the nucleus of my atom. It is going to have 9 protons and 10 neutrons. Then I need to get to my shells. My first shell that is closest to the nucleus of my atom can only hold 2. So we know we start with 9. 9 minus 2 means we'll have 7 left after we put our 2 into our first shell. So first shell will have 2. Our second shell can hold up to 8. We only have 7 left, so we can put all 7 of them. 1, 2, 3, 4, 5, 6, 7. And it would look something like this. So again, questions you might get like on an exam could be something like, how many protons are there? You get that from the atomic number. Could be, how many electrons are there? You can get that from knowing the atomic number. It could ask you how many neutrons, and that's taking atomic number minus atomic mass. It could ask you which structure matches the element it gives you. So you would see a picture of this structure and have to identify it. But then the other kind of question you could be asked is, how many valence electrons are there? Or how many more electrons does it need in order to satisfy the octet rule? So if we're looking at that, valence electrons are just the electrons that are in that outermost shell. So for fluorine, it has 1, 2, 3, 4, 5, 6, 7. 7 valence electrons. If it's asking us about the octet rule, then that means it needs 1. From that information, you may be able to figure out what type of bonding it would do. It's much easier to gain 1 electron than to give away 7. It's easier to share when we need something like 4 electrons than it is to gain all 4 of them. So knowing these valence electrons, knowing this dot structure is useful in figuring out what kind of bonds our elements will make. All right, we're going to go back to the periodic table one last time, and then this way y'all can work sort of with me as we go through one, but I'm going to kind of pause and let you fill it out as we're going through. So let's pick one that maybe you won't see too often, but isn't too large. Let's pick, how about magnesium? So if we take a look at magnesium here, what is going to be the atomic number? If you said 12, good work. What is going to be the atomic mass? If you said 24 or 24.3, or you wanted to round it to 25 for some reason, that would still work. You'll never have to do the rounding. It will be done for you, but it's 24. All right, let's go back to our Rocketbook. Then let's do some of our questions that we might get. So let's look at the number of protons, the number of electrons, the number of neutrons. So then our first question becomes, what is the number of protons? Well, I'm going to pause here and let you guys answer. All right, so if you said that there is 12 protons, then you would be correct. There are 12 protons. And we get that from our atomic number of magnesium. And again, protons are the positive charges. How about the number of electrons? If you said 12, then you would be correct. 12 electrons. Those are our negative charges. And we know the number of electrons because we know the number of protons. Okay, how about the number of neutrons? How do we find that? If you also said 12, then you would be right because neutrons are the atomic mass minus the atomic number, or our number of protons. And again, remembering that our neutrons have no charge. So in our example here, we did 24 minus 12, and that gave us 12. Okay, next up is to draw our structure. So where should we start? I personally like to start with the nucleus. As you get good at these, you'll skip actually drawing the protons and neutrons, and you'll just make the shells. But let's go ahead and draw everything out. So let's start in the nucleus. What two items should we put in our nucleus? If you said that you should put the protons and the neutrons, then you are correct. So you will need 12 protons and 12 neutrons. And I'll let it catch up with a picture for y'all. Oh, come on, take the photo. There it goes. All right, now we need to do our shells. How can we do our shells? We need to look at our number of electrons, but we need to remember that with our number of electrons, our first shell can hold 2, and then our other shells can hold up to 8. So let's start. We have 12 electrons. We're going to fill in our first shell. That will have 2. Then we'll need to fill in our second shell, which can hold up to 8. So we're going to put all 8 into that shell. But we still have 2 electrons left after we do that. So what we need to do is make another outer shell. Again, that shell can hold up to 8. We only have 2 left, so we'll put the 2 that are left. The next question is, how many valence electrons does magnesium have? If we look at our valence electrons, that's the number in the outermost shell. There are 2. With 2 electrons in that outermost shell, it's pretty easy to give them away. So this will probably do some ionic bonding and give away those 2 electrons. How many would it need to fill up this shell to have the octet rule satisfied? Well, it would need 6 more to make a total of 8. All right, guys, I really hope that this was helpful and useful to you. If you were struggling with being able to make these structures and know the difference between atomic mass and atomic number. As always, if you have more questions, please feel free to use the extra resources on the D2L, to use the practice worksheets, to watch the videos. Or if even all of that fails, please feel free to ask. I'm always more than happy to go back over this topic with you guys. But thanks for watching. I hope you guys have a great rest of your day.